Alright, in this video we're going to do a little more practice with medians and equations. Again, remember the median is a segment that goes from the vertex of a triangle to the midpoint of the opposite side. And all three medians will cross each other. They are concurrent at a point called the centroid. All right, and that should be in your notes, by the way. All right, now, as we talked about before, a little fact about the centroid is that it divides each median into two parts, one of which is twice as long as the other. So this is two parts to one part. And we're going to use that in this case to set up an equation, because we're given a couple of expressions here for these lengths. We're going to solve that equation for x, and we're going to substitute it back into the expression to find, in this case, LV, or the distance from L to V over here. So let's take a look at what we're given. We've got LX, so this is LX right here. That's this distance here. And then we've got XV over here, and that is this side right there. So LX is going to be twice as long as XV, or LX equals 2 times XV. I think it's a good idea to always write this out first so you just don't get confused. All right, so let's take a look here. Next up, we're going to go, well, LX, what's our expression there? It's x plus 4 equals 2 times, and make sure you put your second expression in parentheses, 2x minus 4. Okay. So first thing we're going to do is I'm going to apply some distributive property magic here. We've got x plus 4. 2 times 2x is 4x. 2 times negative 4 is negative 8. Now, we only want to have x terms on one side of the equation, so I'm going to get rid of this x over here. Of course, I have to take an x away from both sides. That's going to leave us with a 4 over here. 4x minus x is 3x, and we still have our negative 8. Now, I want to isolate the term that has the x, so I need to get rid of all the other terms. In this case, this 8, negative 8. We're going to do that by adding 8 to both sides. So we still have our 3x here. Negative 8, positive 8 to cancel each other out. 4 plus 8 is 12. Now, finally, we're going to isolate the x itself by dividing by 3, the coefficient of that x. That's going to give us 4 equals x. Now, in the end here, we're supposed to find LV, the distance all the way across. Well, LV is equal to LX plus XY. So let's set that up. LV equals LX plus XY. So let's see. We've got LX is x plus 4. I'm just putting the parentheses in there to kind of set them off so we can see it a little better. And XV is 2x minus 4. Okay, so let's see. Let's combine like terms here. We've got an x and a 2x. That's 3x. And then we've got positive 4 and negative 4. They're going to cancel each other out, make 0. So now we can substitute our value for x, which is 4, into this expression. And we get 12. So LV equals 12. Remember our steps were, first of all, we had to take a look at what segments we had expressions for. We had to figure out what their relationship was. And we saw that the relationship was that LX was twice as long as XV. We set up our equation accordingly, solve our equation for x. Then we had to go back and substitute our value for x back into the original equation and solve for x, and find out what the length of that segment was. All right, let's do another example. In this second one, we're supposed to find YQ, which is right here, and we're given that JY, that's this segment right here, is x plus 2, and that JQ, the whole long length here, is 2x. Now remember that this JY makes up 2/3 of the entire distance, and YQ makes up 1/3 of the entire distance. So we're going to set up our equation to say that JY equals 2/3 of JQ. And oftentimes we're dealing with fractions. If you say 2/3 or 1/4 or 3/4 of something, multiplication is the operation you're going to use. So let's start by putting our expressions in here. We got JY is x plus 2 equals 2/3. And always use your parentheses here. And we've got 2x. Now previously, we started this out by just multiplying both of these things by 3. Well, let's just go ahead and do that again. You don't have to, but it just makes things kind of easier in the end. Make sure when you're multiplying by 3, you put your parentheses around this because you're multiplying everything in here by 3. So this is going to give us, using our distributive property, 3x plus 6. And this, the multiply by 3 just cancels out this divide by 3, and you get 2 times 2x. And let's see, we'll multiply that out. We get 3x plus 6 equals 2 times 2x, 4x. And then, I only want variable terms on one side, so let's get rid of this 3x here. Of course, we have to take away 3x from both sides. That's going to leave us a 6 over here. 4 minus 3 is just 1x, and we'll leave the 1 off. So it's 6x. So now we solve for x. How are we going to go back and find YQ? Well, you'll notice here, YQ is what's left over if I subtract JY from JQ. So we could write that YQ equals JQ minus JY. And we'll put in our expressions here. JQ was 2x minus, and this is important, you need to put your parentheses around this. We're taking away x plus 2. And the reason that's kind of important, and I've made this mistake many times myself, is that when you open up these parentheses, it's minus x and also a minus 2. And what you might be tempted to do is just write minus x plus 2. Be careful with that. When you have a negative sign out in front of the parentheses and you distribute it through, everything inside changes sign. If it's negative, it becomes positive. If it's positive, it becomes negative. So let's see. 2x and a negative x is simply x, and then this negative 2 just stays there. So we simplified our expression, and now we're going to substitute. I'm going to put a little dotted line in here. We're going to substitute our value for x, which was 6, from up above here. Minus 2 equals 6 minus 2 is 4. So YQ equals 4. And if we were to go back, if YQ is 4, then YJ should be, or JY should be 8. And if because it's twice as big as YQ. And if x is 6, we'll go back up to our original expression. JY, 6 plus 2 is 8. So it works. All right, so remember your steps are, you got to figure out first, what are you trying to find? And then look at what you're given. Figure out what is the relationship between these two segments. Is one of them 2/3 of the other? Is one of them twice as big as the other? One of them half of the other. There's different ways you could write it. But remember, typically you're going to end up with 1/3 or 2/3 or twice as big. Look at what it is. All right. Next, you're going to set up your equation accordingly, and I recommend you always write this out, and then just fill in the blanks with your expressions. Solve your equation, and go back and substitute. And if you're at a loss for what to do exactly, substitute your x for all of the different expressions. Get actual numbers, and then deal with them afterwards. All right, to find out whatever it is, of course, that you were supposed to find. Good luck!